Alright, today we about to do more functions, man. I'm gonna start off with a recap of Tuesday, going back over the logic and like the syntax of a function. I'm gonna go into calling and creating functions. That's mostly y'all helping me create some functions. And then tricky functions is gonna be like void functions and when to use parameters, when not to use parameters. And how to understand, like, how do I take this prompt and understand how to convert that into the accurate function. Questions before we start? Cool. So as a recap, functions and mathematics. That's how I started off Tuesday's lecture. I said when we think about functions in math, right, we have some value x. We have some value x. We want to do something to it, i.e. run it through a function, and then we get an output value, which we call y. So we take x, run it through a function, and we get an output value called y. In this case, x is the input, y is the output. Therefore, y is dependent on x. Depending on the value we have for x, we get a different value for y. So looking at a diagram, again, we have x as the input. X is our input. It's going into the function. The function distorts it, changes it, maybe even gives you back the same value, but normally it gives you some different value because the function is mutating that value. So an example I gave Tuesday, I said my function in this case is to square the input. Whatever my input is, I want to square it. And then output it. So if my input was 3, on Tuesday we said the output would be 9. I took that 3, I squared it, and then I got my output. So my function in this case is squared. I'm raising it to the power of 2. Raising my input to the power of 2, and I'm outputting that value, returning it back. So the user gave me a 3, I gave him back a 9. Questions so far? So again, we still have the same concept of this input-output system, but in programming, we don't call it input-output so much when we're using functions. We call it parameters for input and return value for output. So again, parameters is just your input to the function. Your return value is the output. Return value is your output. So that's how we return the value or give a value back to the user. The user is giving us a value as a parameter. They're giving us a value as a parameter, and we giving some type of other value back as a return value. So still this input-output system, but we don't use those terms so much in programming. We say parameters and return value. The example I gave was the vending machine, and y'all helped me design the vending machine. We said we still have this input-output thing, but the input and output for the vending machine was a little different from the math example. We said the input in this case is the code that we press on the vending machine. This is how we tell the function what our input is. We input a code, maybe A7 or D4, whatever the code is. We put that in the vending machine, and we get an output. What was the output we said?
The snack, right?
The snack.
Yeah.
The snack. So we input a code, we get out a snack. So X is the code, Y is the snack. We always have this input-output type of relationship when it comes to functions. The key things I noted were, depending on what we gave as like our code or our X, we got a different value for Y. We got a different snap. And then lastly, we don't know how the internals of this vending machine work because we didn't create it. Likewise, with certain functions we use like substring or length or whatever, we didn't create those, so we've never seen the lines of code that actually do the heavy lifting, that do the work. We just know that this thing is supposed to do this specific job, so we're going to try to use it based on how the person has designed like this interface to tell us to use it. So we know we see this keypad, so we should press 2 buttons, a letter and a number, and then it's going to output something specific. It's going to output something specific. Same with functions. They have a name, and when you see the function, you know it needs to input like certain numbers inside of it, like substring. You know it requires you to put in 2 numbers. And as an output, you're going to get back a certain portion of that string. So for every single input combination, you have a specific output. Likewise with the vending machines, the same exact concept. So I also gave these examples. So this is how some sample code might look of us using functions, right? The function we're using in this case is called what? What's the function we're using? Square root. Square root has a certain type of input. It wants you to input an integer or a double, I suppose. But in this case, we're giving it an integer. We're giving it our integer. That's our input. That's our input or parameter. The parameter in this case is the 25 for the first function code. And the output in this case is 5. So we input something specific. It runs that input through the function, and it outputs a specific value. Outputs a specific value based on the input. In the next case, we have the same exact function, so the same steps apply, but it's using a different input. Therefore, it's going to use that different input, run it through the function, and give me a different output. So the steps that it's going to go through are the exact same. But depending on the input, the output is going to look a little different. Same with the vending machine. If I put in 2 different combinations, I'm going to get 2 different snacks. It's going to do the same exact thing. It's going to read the input. It's going to go to that place on the vending machine and grab the snack and dispense it. It's going to do the same steps, but the input determines the output. The input determines the output. So y'all gave me these last time, so I'm going to try to just go back to them. I'm not going to ask y'all to say the same thing, but we said with the length function, we know that when we call it, like in this example, it never ever takes any parameters. The length function never takes any parameters. It doesn't have any inputs. So in this case, we would not have any parameter types. There's no parameter types for the length function. We never put anything inside of those parentheses. As for return type, we know if we ever call length on some string, it's going to give us the number of characters in that string. That can't be a double, that can't be a bool, that can't be a string. It's going to always be an integer. So the return type for that would be an int. And we have the at function, right? We call that on the string. We know we always have to give this function an integer because we want to know what position in this string are we trying to retrieve the character for. So in this case, our parameter type is an integer. It's an integer. If I give it anything other than an integer, it won't work. If I gave it 2.5, it doesn't have a position 2.5 in the string, therefore it can't work. As for the return type, we know .at gives us a char. It gives us a char. So all these functions have specific makeups to where you have to give it something specific if it accepts parameters, and it's going to give you something back that's very specific. So if you ever, mismatch and give it the wrong thing, it's going to complain. It's going to always complain. And lastly, we have substring. In this case, we always provide substring with either 1 or 2 integers. 1 or 2 integers. So my understanding of this function is there's probably 2 substring functions that the people who built this language created. One of them takes 1 parameter, the other one takes 2 parameters. One takes 1 parameter, the other one takes 2 parameters. Depending on how many parameters you provide, it'll call one or the other function. So it takes 2 integers because it wants to know what is my starting position and how many characters do I take. There's no way I can give it a bool or give it a string or give it a double. Like, it has to be 2 integers logically. And the return type of substring we know is a string. It's a string because it's giving me a portion of a string. It could be the whole string, could be 1 character from the string, but it's always going to give it to me as a string. It's always going to return back a string. Questions on this slide? So again, why do we need functions? The main reasons I would say are reusability. If I create a function one time, I go through that headache one time, I get it right finally, I can reuse that function as many times as I need to, and I can make it dynamic enough to where it can work to suit like all the cases that I may need it for. For example, substring. The person who wrote it must have been pretty smart. They said, let me make this dynamic enough to where the user can give me two numbers and I can give them back that exact portion of the string. So you don't have to go through that headache as the programmer. All you need to remember is the name of the function and to put two numbers in it. So they do the heavy lifting. We just need to remember the function and how to use it. Also, it makes our code cleaner. So remember, functions are they have user-defined names. So when I create a function, I name it what I want to name it. I can make it as descriptive as I want to. I can even add comments throughout the function. I can make it super descriptive to where the person using my function knows exactly what it should do. The length function, we know it probably has something to do with length. Substring is taking a sub part of a string. That size is giving me the size of a string. Like, they're descriptive enough but concise to where when we call these functions, we have some idea instinctively of what they're supposed to do. That's the idea, but that's the idea behind naming functions and variables with intent. The better we name our variables and functions, the better somebody coming in can read our code and actually use our code. And also, lastly, it makes it easier to maintain and read the code. So let's say I want to go through the parts of a function, right? Let's say I'm creating my own function. This function is called, what's the name of this function? Add. Everybody see why the name of this function is add? You see add? Boom. So reading left to right, we know we start our function with the return type. This is, after we do all of this computation, this is saying I'm going to return the user back a double. So you're promising the user, when they give you some input, you're going to give them back a double. So you always have to stick to that promise. I can't decide, all right, I'm gonna tell you I'm returning a double, and then inside my function I return a string. That's not going to work. You guys stick to your promise. If you say you're going to return something specific, you have to do that. Have to do that. Question.
What's in the parentheses from 1 to 1, 2? That's it in the base added.
Kinda, sorta. Those are the values we're going to use within the function to actually do the calculation. So basically, I'm saying, all right, when somebody calls my add function, they need to provide two doubles. We're going to call them num1 and num2. And we are going to use those two doubles to calculate a sum, and we're going to give that sum back to the user.
What's weird, it's like initializing it, like, say you do int 0 equals 0 equals like sum.
So these don't get into, so when we create a function, we don't really get into specific values normally. We leave it vague because the user is going to give us certain values. So when they call this function, when they call the add function, let's say in my code I have int main, right? Boom, boom. And let's say somewhere in here, let's say somewhere in there I want to call the add function. I would say ADD. I always reference it with the name of the function. And this function we know takes two doubles. So I gotta provide it with two doubles. I can say 0.0, comma, 4.0. This is how I would use the function. That's creating it, this is using it. And so because this is going to return me back a double, I would want to probably create some variable. And I'm going to store it. I'm going to store the result of whatever this gave me. So we know if I add 0.0 and 4.0, what is that going to give me back? 4.0. So now if I were to go to print out the sum, this will print out 4.0 because the prior line calculated that 4.0.
So, even though you put some in the actual function, would you be able to use that?
Right. Yep. So whatever names are used, even in this line, any names that get used with the function, they only exist. They only exist when you see it right here. So I can reuse anything because int main is a whole different function. So I can create something called num1 and num2, and it has no idea about that num1 and num2. So they had no like real communication in terms of variable names. So I can reuse variable names that existed here, because I'm sure somebody somewhere, some programmer created a variable called or like they have a function that has some variable names, but we're still able to use them because they have no communication with each other. It's just if we create a function, right? Let's say int main or add, and we have some variable called sum, we can't recreate that same variable within the same function though. So variables are tied to the scope of that function. Other questions on that piece? Cool. So now for calling and creating functions. So I want y'all to take some time, get in groups, work with your partner, and go through this example. We want to create a function called is voting age. Is voting age. What this function should do is it should take the user's age as a parameter, take the age as a parameter, and return true or false if they're old enough to vote, which is 18 or older. Take about 2-3 minutes to do that. And I'm gonna ask y'all to help me put this function together because I don't know how to do it.
Do you want us to prompt the user, or you just gonna do it?
So it's gonna take the.
Well, we can prompt the user inside of the function. So.
It's gonna take the user's age as a parameter.
Oh, okay. So
Okay.
just do age inside
It's about an assignment.
No, this is like my own.
Alright, I'm gonna like. Nah, I just don't be trying to mix like class stuff. I be having it recorded so people can go back and look. So I don't be trying to like be all over the place.
I had put some stuff. You can just read it.
Alright. What is it about?
Given an array of integers, return the array back to us.
Oh, it's a interview question. Oh, alright.
Or just return, or I guess just return.
I really just wanted to know if I was going down the right direction.
Basically said complicated. That's not how we want to like start from the end.
Oh, never mind. I know how to do it. I'll put it backwards.
Nah, because you're doing histogram. Oh, wait, if they're 18 or older? Oh.
Alright, so that's.
Right. And then the middle part is not right.
Right, it's on the line.
Like close, but you not all the way down. You're not gonna include zero. Zero is the first character. I mean the first element. You need that.
I knew the last one.
We need all of them. You need all of them, right? You're returning the same array but backwards. So if you don't include zero, then you're not gonna ever get the first one. Basically what I'm saying. So if you do greater than zero, you're never going to take zero.
No, I know. I see what you're saying now. I was gonna ask. I was basically doing.
Yeah.
Array. Yeah. I mean, if you want to do that, then you need to say.
Oh, you're missing one.
You need to say the size of the array.
Can I get a lower tracking ID?
I don't even get. final array to be the same size as the beginning array because it's gonna be the same one just backwards. So because you initialize it with 0 elements, you need to like give it a limit to say like how big to create this array. Because the vectors can change in size. Array is fixed size. Once you create it, it's gonna always be that size. Alright, we got an idea? You got an idea? You got a question?
No, I got it now. Yeah.
Alright, bet. So let's see. So remember we got the 3 parts: return type, function name, and the parameters. So I already gave away function name. What's the return type of this function? Bool. What is the parameter for this function? And age. So how will we create this function?
If age greater than or equal to 18, return true.
Alright, so if age is greater than or equal to 18, return true. Perfect. Good work. That definitely worked. Any questions on why this was the answer? So basically just step through it for like 10 seconds. This function is going to read whatever the user entered as input, take whatever they entered as the input, and it's going to say if that value is greater or equal to 18, we're going to return true, and that's going to stop the function right there. Nothing under that is going to ever execute. So even if I had lines of code down here to say whatever, like it could be anything, some calculations, anything that comes after that return statement, it would never happen. It would never touch that line of code. And then in this case, let's say they were 16, it will end up returning false because it doesn't meet that condition. They're not greater than or equal to 18. So even in that case, if I had some code that was under here, it would never execute. It would never execute. So basically I know after this if else block, the function is going to be over on rip because if this is not the case, the else has to be the case. So I only got 2 options. Either you are able to vote or you're not. The function ends with one of those return statements.
You say return. Is it printing?
No, it doesn't print. It doesn't print until I do something like this right here, where I actually do a cout. So when you think, I know what you mean. It's like, all right, you're giving a value back, but is it going to show it on the screen? Nah. It's just, it's so hard to like articulate it without like confusing you.
The function essentially, right, inside of it is going to store the result, and it's only until we then like see out it that's going to display the result.
Right. Okay, yeah. Like bro said, it's going to give it back to the user, but it's not going to display it on the screen until we do like a cout to actually display it. So it's like it's computing stuff, and we saving it as a value. For example, this might actually make some sense. So if I do, let's say I had string. Let's say I had something like this, right? I create a string. The name of it is str, and it has a value of hello. So it has 5 characters in it. If I call this function length, it's going to check how many characters are in that string, which it knows is 5. So it's going to return me 5. But nothing from this is going to make that 5 print to the screen until I actually do a cout and I like try to print out the length. So return just means fetch me a value and give it to me so I can store it.
Should you like put the cout inside the function?
Normally you don't want to cout in the function because that means every time somebody calls your function, it's going to print out. Yeah. You only want to print out in certain like normally like in real life when you debugging and something doesn't work, then you will use like print statements to see what is the value actually like giving, what is the value that is giving me back. In the real world, you're just using a bunch of return statements because you want to go retrieve a value and use that value to continue with some other work. So I'm gonna try to make that piece make more sense, hopefully. But general rule of thumb is when you're creating functions, you very seldom use cout. You're not really printing stuff. You just computing the value and returning it back to use that value to go do something else. So let's go over some tricky functions. So void functions. Anybody still confused, like what is void, why we use it, when will we use it? Everybody understand it? So void functions. The three ideas I could think of are that void functions do not return any value. Void means do something but don't return me a value. Don't return me a value. Do some work, but don't give me back a value. So just like I said in the second point, these functions are going to do stuff. They're still useful. They still do stuff, but they don't have anything to tell you back. They don't have any response for you. They don't have a response. They don't have any response or output or return value. So a void function is useful because it does stuff, but it doesn't return anything back to us. So the examples I gave Tuesday were the following. Let's say there's some function that exists called open browser. I provide it with a string that represents a browser like Safari or Firefox, and this function opens the browser. It just opens the browser for me. I don't need any values back from calling that function, right? All it's going to do is open the browser. Once I see the browser open, I know that function successfully worked. So in that case, I'm not computing anything. I'm not waiting for a value back. I just want it to take action and do what I told it to do, and then it's over. Same with deliver package. I provide it with an address, and it delivers the package. I'm not sitting there waiting for any values back or a response. It's just going to do what I tell it to do, and then it's over. Likewise, for the last two, log in and show error message. These are basically just commands that I'm giving, and I don't need a response back. I don't need this thing to talk back to me or give me anything back. So I'm going to say these would be like my void functions. These are void functions. They're going to do stuff. They're super useful, but they don't return us any values. They're not computing anything, so they don't have a return statement within them. Any questions on that?
Could you call a void function in there?
Yep. We can call a void function from anywhere. It's just we won't take it and assign the returned value to any variable because it doesn't return anything. The second type of tricky function is no parameter functions. So you might read a prompt, might read the homework and say, all right, does this need parameters? A lot of times in the homework, I'll throw in there, use these parameters. But let's say I don't tell you that, and you have to just take an idea and translate it to a function that makes sense, which is what you're going to get in the real world. They're not going to tell you how to make your functions. They're going to tell you build X, Y, and Z, and you got to know what functions you need. So a no parameter function, hence the name, just doesn't take any parameters. We can identify these or when to use them, when to create them. When the function is pretty direct, it really doesn't compute anything or process any data. It's just going to take action, and it doesn't need the user to really provide us with much to do our job. So we have everything we need, or we can get it inside the function. So we don't need the user to give us any data to do our job. For example, if I'm adding, right, that has to take parameters because I need two numbers to add. Without those two numbers, I can't add. So it's basically like you're dependent on the user to do your job. So if I have a no parameter function, that means I'm not really dependent on my user to do this job. And I got some examples, I think, in the next slide. And so this is a very, very important point. I can still have input with a no parameter function, it's just gonna have to come via cin or getLine. So if I have a function, let's say it doesn't take any parameters, I can still talk to the user within my function by using cin or getLine. I can say enter, let's say I have an add function, right? If I don't want any parameters, I can, in my function, say cin or enter two numbers, do a cin and store those two numbers, add them, and return it back. I can still kind of replicate the same behavior with a no parameter function. The only thing is, every time somebody calls that function, it's going to do cout and cin, cout and cin, and that's normally not what you're going to see in industry. Normally, you're passing values as parameters from function to function, not doing a bunch of cout and cin statements. So yeah, like I said, every time a function that uses cin and cout gets called, every time that function gets called, it's going to do that. Every time the function gets called, it's going to do that. So let's say you're trying to do some homework and you get tired of having to type in user inputs to move on to the next part of the assignment. In that case, you can probably just start passing values as parameters instead of having to always type in a value just so it goes to the next line of code and type in a new value. Like that can kind of get long, especially in homework assignments. So consider passing values as parameters instead of trying to rely on user input via cin and getLine. So I'm gonna explain some examples of what I mean by that. So let's say I have these two functions. Neither one of these take parameters. They both have empty parentheses. And the reason for that is the first function just says flip light switch. Flip the light switch. I don't need any information from the user to be able to do that job. I know I go up to the light switch and I flip it. If it's on, I turn it off. If it's off, I turn it on. That's it. I just flip it. I don't need to talk to the user to be able to do that job. Secondly, close the front door. I don't need to talk to my user to be able to close the front door. Therefore, I'm not relying on any like input to be able to do that. Bless you. So basically my explanations were neither one of these rely on the user giving us any data to be able to process that task and finish that task. And these were void functions because they're not returning anything. These are just actions. These are just commands. They're going to happen and the function is over. There's no need for me to return an int or a bool or a double in any of these cases because what would those things even represent if I'm closing the door or flipping the light switch? Feel me? So there's nothing to return back. Questions on these? All right, let's see. So we got another task. And this time we want to create a function called greet, and all it should do is print out hello. This function should just print out hello, and it's going to be called greet. I want to see how y'all will write that function. Give it like 30 seconds to a minute. Should be a one line of code inside your function. You need the header, but you also need the one line inside of there to make it do that. Review. Huh?
Hey, you know she trying to start her test like you too.
Like me? What did she do?
Like just look at it, it's just like your review now. Like the first question, I think she gave us the wrong answer. Now I'm looking at it. It says input is 5, so it would print out live Prosper.
Wait, Cody, you doing a review?
Right, it would.
She said it's just Prosper. That's not the right answer.
Right, nah. Huh? Yeah, you right. Huh?
It's not just Prosper. It's live Prosper. But she told us it was Prosper. Hey, if you can get the back.
Oh, nah. Alright, we got this function.
It's supposed to be one line.
Yeah, it's
One functional line to be able to do this thing right here. We got it?
Yes.
Sure?
Yes.
Alright. Alright. So we should have something like this. Real short, sweet. String greet.
Yes.
Where y'all get that from? I ain't say it should return anything.
I said void.
Oh. Void. I never said return anything. I don't want it to return me anything.
Damn. You didn't see oh.
Nah. See, I was just action.
Oh.
And it doesn't return anything.
Oh. I didn't.
So it should be void. I never say I wanted you to return me anything. Gotta take note of what the question is actually asking you. When you see return in the prompt, then you return. Then you return. So what would my parameter be for this one? Nothing. Nothing. So this is a void function that takes no parameters. We don't need anything from the user to be able to do this job. All we doing is printing hello. What we need a parameter for in this case? Nothing. Also, we're not returning anything, therefore it should be void. So how would I write the code for this function? Cout hello. And if I wanted to add an inline at the end, I could. This is it. All the functions said they wanted me to do is print out hello. All I'm gonna do is print out hello. It didn't say return it back. It didn't say anything about inputs. So I'm gonna keep it simple. Keep it simple. Huh? Do more as in what? You gotta give me context as to what you mean by do more.
So all it asks for is say hello, right?
Uh-huh.
For the cout, could we just put like a string greeting the value of hello?
This function, we said all we want to do is print out hello. So we shouldn't. You mean like here, where we create a variable? We could create a variable called greeting and then print out the greeting if we wanted to. But that's like, it's using memory for no reason. Like we creating you get what I'm saying? But that is another way to do it, for sure. So boom, let's take what we just did. And let's make it more dynamic. So now we wanna create a function, let's say a new function called greet user. Greet user. The concept is gonna be the same. It's gonna still print out hello, but in this case we wanna take the user's name as a parameter. We're gonna take the user's name as a parameter, and when we print out that greeting, we're gonna append the user's name to the end of it, and then the exclamation mark. So take like a minute to think about how can we upgrade our previous function to do this. CN statement. Sure? Yes. Alright. So what we got? Void. And so what's the parameter? String name. String name. Remember, we still didn't say we want to return anything. We still just printing. Printing means, normally when you see just print out something, it's going to always be void. 99.987% of the time it's going to be void. But in this case, we said we actually do want parameters. I said take the user's name as a parameter. When I say parameter, I mean parameter. I don't mean prompt the user. If I want you to prompt the user, I'm going to tell you. So how will we create this one? We want to print out hello. Oh, my bad. We want to print out hello and then the user's name and the exclamation mark.
You create his name.
Oh, like that.
No. Go back. Put a space. There we go.
There we go.
Oh, just
Oh, yeah.
so boom. This'll hard code the hello, print out the hello. It'll say, all right, I have some variable called name. So whatever the user passed in as the name is just going to use that right here. It's going to use that value. And then it's going to append this exclamation mark to the end of it. And then it's going to end the line. That's all this function is going to do. It doesn't return anything, but it does accept the user's name as a parameter. It accepts the user's name as a parameter. All right, it's the last one. Last one. So in this case, what we want to do is create a function called getClassification. It should take no parameters. No parameters, but we want to prompt the user for the classification
Oh, okay.
and return it. Get that one like minute 30. Let me make sure I got the say it's a string.
Yeah. But we see in after the main, right?
Right.
Alright, so we'll start creating a function. String, yeah, string. Oh yeah, you're right. Got it. Then I think it is in like that. There's no parameter. Exactly. No, I'm not putting this out.
Oh, okay.
Oh, prompt user for the classification.
Wait, so you able to do a function with no parameters?
Yeah, it's a CN statement, but it's outside of in main.
Right, length is a function with no parameters.
So I don't think we can do it.
Length is a function with no parameters.
Oh, type shit. Bro, just be like, bro, you on team, just ready for this shit. Just like, damn, you just woke up.
Oh, I think we gotta do this statement.
Shit, like, my fault.
Be like,
I be doing it, yeah. It's like, but
That's what I was thinking.
it's not like you notice it. It's like you just, it's like type shit too. You right.
you got to, bro. You can't overlook it, bro. We got an idea?
Yeah.
We need more time, or we all? You sure? No. They got it. No parameters, and this function should prompt the user for the classification and then return it. You got it? All right. I hope my next slide is right. I don't remember if I don't remember creating a. Oh, I bet. All right. So what's the return type of this function? String. I ain't mean to highlight it, but string, and then what's the parameters? No parameters. We good on that so far? All right, boom. So how would I go about creating it?
You start reading your string classification.
Mm-hmm.
See out what's your classification.
I'm gonna just say class because I don't got space. Then let's jump.
Return classification.
Huh? Return get.
Turn it and then put it in a variable. I mean, a function.
Because you're getting the classification from user input, and then
Yeah.
you're gonna return it.
Yeah. So don't mind my spacing. I don't know what was going on right there. But basically, yeah, we create the variable because we always have these three steps when we're doing user input.
I didn't know we can put it above.
When we prompt in the user, we always do those 3 steps. We have to. We gotta And you said you didn't know we could like create variables inside of the function?
No, I didn't know we can put it all above int main.
Oh yeah. Mm-hmm.
Alright, bet.
Yep. So everything we can do in int main, we could do in our own function. Every single thing. We can create variables. We can call other functions from this. Like every int main is a function itself, so the same rules apply.
Okay.
So just like we always do, we create our storage for this input. We prompt the user for the input, and then we store it. Once we store it, we have everything we need. We fulfill the requirement for getting the classification. We just return it back to the user. So since we promised we was gonna return the string, we have to have this statement here that actually returns that string. All right, that's all I have for like lecture. Do you? So what I was about to say is, so these questions, did anybody like go through these and do these? Y'all did them?
Oh.
It's optional, but if y'all want, we could go through these and like actually do more hands-on practice, or so I think we did the first two on Tuesday though. Number 4 is a little tricky, so let's see what number 3 is talking about. Number 3 says create a function that accepts an integer. I didn't mean to repeat that. It accepts an integer and returns true if the number is even and false if it is odd. Y'all want to do it like individually, or y'all want to like do it as a group?
Can we try it individually?
Try individually first.
Yeah, that's cool. Oh god.
Yo, Voltron was what's up.
Oh, so how did you sign that? It only actually gives you that one option. Because you can, the switch only says this is for 2, 3, and 4. It says switch. It's like you was supposed to. I don't know. It's like
Because I was looking through the assignments.
we did. It was an assignment on switch cases. It's just like something you gotta do.
Oh, because that's why she marked me down on my assignment. She said you switch. I didn't switch. Did you say only one with one spot?
Yeah, because it says switch and then it says cases. It says
Switch
case.
means just
and then-
false. Does switch just mean like out of bounds?
Nah, it's like a big if. It's like a if statement basically. Yeah, it's basically like an if statement. Saying like if cases 2 do this, cases 3 do this, cases 4 do this. But it will go to default if it's like none of those cases. But she's saying the question is asking what would make it default, which is if the case is 1, because you don't have case 1, and if case is 5, it's just case 5.
Are you sure it has to be that over?
Bro couldn't sit right with that.
Nah, I definitely couldn't. Definitely couldn't.
I do not. You're running.
Brandon, you got any else? No, I ain't got any else.
I saw a 15-year-old Asian
What?
Been here for
Coder?
2 seconds.
doing the Google intern, like
Uh-huh.
he was in high school and shit.
He did good. Like,
That nigga was like, he's in high school interview questions, and some random dude that be doing do like interview questions popped up. I was just like,
You could. Oh, yo, we see you on the same track.
it was talking about algo.export.
I don't know what it is.
I think that's right.
We got an idea of how to do it? Number three?
I think we got it, bro.
Alright. Alright. Let me see something. What we got?
Even parentheses, int, num.
Yep.
Okay.
Isn't this just like the one we did for the age one?
Yeah, basically.
If
Mod 2
equals 0, return true, else return false.
Yeah.
Oh, so we got that.
Yeah.
Hey, why don't you show them just the return false instead of else?
Eventually. Can you use huh?
Yeah.
That's just the name it shows.
Yeah. Mhm. So you wanna normally, just like when you name stuff in int main, it's like with intent. Like you wouldn't name this. We keep it general, like x in num, something general to indicate like when it gets, because some functions are more than 5 lines, right? It could be 100 lines, and when you get down to the 100th line, you want to write. So if you see x or num, you know it's a number. You don't gotta scroll all the way back up and say what was the data type of this thing. So you want to kind of name it in a way that kind of gives away what is represented and what it is. So x will work, num will work, n will work, something like that. So that's how we would do that function. Any questions on that one? All right, y'all want to attempt this second one?
Yeah. Bro, the thing about it is, longer we come to the phone, like it is at the end. Yeah. I'm trying to figure out the name for it.
This one a little tricky. I feel like you should try this one. This one.
So it's gonna be the one, the X one to go inside. I was looking.
No, it's
You know Bonix? You know what Bonix is?
Golden Wise.
Not a quarterback.
Oh, okay. I'm thinking.
You know who that is?
Listen, I have previous experience.
Look.
Listen, okay, I work at a grocery store, okay? I can have that.
Not even trying to like. Where this nigga at? I don't know.
Do we have an idea?
Oh, yeah, I named mine Powder.
Okay. Alright. We got some idea of how to do it? We
I think
finish
I
it?
got an idea.
Sort of, yeah.
Alright, let's work on this one together. This is a little tricky one though. So what is it gonna return?
It's already returned, it's a number raised to the exponent. It's our final number.
What is it? You said ant?
You have to answer.
Number and power. Oh.
I'm gonna go pile dupe. We could go pile dupe.
Int num 1.
I spelled it wrong. D-U-P-E?
Oh.
Dang. My bad. Num 1. And
You can put num actually.
num
I put number in.
exponent.
Yeah,
Oh, that's smart.
I would definitely do that. So that way when you using them, you don't get confused of which one is which.
yeah,
Like
it just makes sense.
name them with intent. So what's my algorithm? What I'm doing? We creating PAL. PAL doesn't exist.
Then you make another one that's int something.
Oh, so that's what y'all did? Y'all just use PAL?
No, I didn't.
Oh. We basically creating it. We creating the PAL function from scratch.
All from scratch.
Num times exponent.
Hmm?
Wouldn't it just be num times the
Wouldn't it be like we use one of these doubles?
Actually, it'd be
Oh, wait,
int
no.
num
No.
is equal to int num is equal to num times
Num.
num times num.
That's if the exponent is 2.
Oh yeah.
I could raise this number to any exponent. So I gotta multiply the number of times that they tell me to multiply, which is the exponent.
just be num times exponent?
No,
Nah.
that's not exponent.
That's multiplication. You gotta raise it.
Exponent means multiply the number by itself that many times.
Right. So exponent would be
So yeah,
equal
what you
number
just did,
times.
num times, like num, and then times exponent.
Nah, you literally just said what he said.
Right.
I did?
Mhm.
My bad.
So I'm gonna give a hint.
Exponent would need to be number times itself however many times.
Oh, so we're almost doing this like the way how I did it.
I'm about to give y'all a hint. So what I would do is, I know that in order for me to get the final product to return back, I need to take this number and multiply it by itself repeatedly, this many times, a for loop. The for loop is gonna run exponent number of times. And I'm gonna constantly multiply and add that back to this. So I'm keeping track of like a running product, and once I'm done the loop, I can just return
Oh shit.
it. So I'm gonna say int I equals 0. I what? Less than exponent. I plus plus. And I can say product times equals num. So I'm gonna always multiply my starting product by the number. And then I'm gonna save the value back into product. So let's say I have, and then what's the last thing I need to do in this function before I like explain it?
Outside, like press enter to
Return product. So what this should do is, if I had product, I'm starting it off with 1. I can't start it with 0 because if I multiply 1 to 0, it's just gonna stay 0. So I had to start it off at 1. So I'm gonna say product is 1. Let's say my num is 5 and my exponent is 2. I know that really 5 raised to the second should be 25. So let's see if this works. So what it's gonna do is take the product, which is 1, and it's gonna say product equals product times the number, which is just 1 times 5. 1 times 5, which is just
Oh,
5.
and then it's a 4, so it's gonna keep on going.
That's gonna give me 5. This loop is gonna run twice because the exponent is 2. So I got one more iteration to go in my loop.
So it's gonna be 5.
That's gonna be, yep. 5 is product now, so it's gonna do 5 times 5. And that's gonna give me
25.
my 25. My loop stops because I did my 2 iterations of the loop.
Yep.
Product has a value of 25 and we return that back to the user. This is, I'm pretty sure this is how the POW function is written. They probably condensed it somehow, but this is the logic you'll follow to do that. Good with that? All right. Any questions about anything else for y'all? For y'all, you know, hit the road. No questions?
Yeah, bro.
Appreciate that, my boy.
Yo, Frog. Yo, Frog. Yo, Frog.
Yo.
You got anything else for us?
Whoa. What's going on, though, bro?
Remember you said you were gonna hand out a t-shirt?
Oh, nah, I don't have that. Nah, I meant, like, nah. I gotta figure out a question and all that.
Bro, you could have did one earlier.
Nah, I don't
bro.
have
You coulda
a
did
good
one
question to do.
earlier.
Bro, this class like comedy, bro. All right, I could give a little drop on the lab real quick. Y'all want a little, you know, a little drop, a little drop. You done? You done? All right. All right, boom. I'm gonna. It might not be much of a drop, but it's a drop. Let me see. Let's see. So let's see. So the drop is really that. Let me see. So really, I'm gonna show you like. I'm gonna show an idea that I kind of realized like, huh? It's the lab. Yeah. You must ain't look at it, my boy. You must ain't look at it, my boy. You must didn't look at it. You might want to throw the towel in for this week, bro. I don't know, bro. All right, this the drop right here. These the whoops. So look, I separated this little chunk. Hold up, I think. All right, bet. So we notice that these 3 chunks are exactly the same, right? For when the current x is 1, we have this chunk which looks pretty similar, but it's like all the lines are not there. Then we have 3 repeated chunks. What you want to do at that point is probably take one of them, throw it in one of the whoops, throw it in a function, call it whatever you like, and you need to figure out how we can make these steps into a loop, return some value. I don't know what it's going to return. Return some value. And then we could get rid of all of this. Dang. At that point, we could just call function 3, give it all the values we need, and since it's going to return a double, we're going to say double some value. I don't know what it's going to represent or what it's going to be. We got rid of that whole like chunk by just calling the function. That function is going like, but since it was 3 chunks, right? It was 3 things.
Right.
We're going to need to do that. It didn't even save my function. So I could just copy the whoops. So we're going to recreate it. I don't know what parameters it's gonna have. It's gonna have some parameters though, and it's gonna have some return value. All I know is these were the steps that repeated 3 times. Hold up. These were the steps that repeated 3 times, so I probably want to keep these and just do like a little I probably want something like this. Some parameters are going to be passed in, or some list of parameters. They're going to be used to do these computations. After I do these computations, I want some result value. And I'm going to return that value so that down here, when I call function 3 and I give it some parameters, it gives me back some value. And that way I got rid of those repeated 3 chunks by just making a loop that runs 3 times to do the same exact thing. So once I do that enough times, I'll have something like this. I'll have something that looks like this. And then I can see how I can further simplify this code, because I still have stuff that's repeating. For every chunk, I think I was printing this at the end. So I could also throw that in the function too, in some function. So that's kind of like your next step as a giveaway. So think about how can we make that function 3 or whatever it is for you, make some loop and have like those repeating steps inside the loop. But be careful about what it's going to return and what it needs to be able to compute everything. And it does need to return some value, but finding out what that value is and when to call that function is a little tricky. So don't try to just tackle it all at once. Don't try to just take a picture of the whoops and copy and paste it and think it's about to work, because it's not. So understand like what you're doing. But that's the next step. Other than that, any questions? We good? All right. I put the homework back up if y'all need a picture. And remember, this QR code is internships. It's a whole website of internship application links. It tell you the company, it tell you the website to go to, and give you a direct link to the applications. So make sure you get that, and make sure you still apply to Google. That's open until like the first week of November, I think. Make sure y'all getting that. And then did everybody do the QR code for at the beginning of class that I put up? All right, yeah. All right.
Yeah, that 10-minute survey that they said.
You say you need to do it? I'm about to take that. Here you go, bro. Oh, the lab.
I had erased that shit though. Yeah, that's why I was. You still gotta.
Facts.